John, and I'm an HVAC engineer, control engineer, and electrician. What I want to show you here, I will use this with this occasion to explain to you a little bit about boilers, control, and safety. As we all know, not a long time ago, we used to use a classic way to control equipment like boilers, chillers, air conditioning, etc. That was easy for an electrician. You could check a contactor, or you could check a overload relay. Also you could check circuit breakers, etc. Lately everything changed, and when I'm saying that everything changed, the business management control has been introduced. This is a COMMONSENSE control. If you wouldn't know how this BMS works, then you have to live with a lot of frustration. If you will see what we have here, we have a water circulating pump. So here's the pump. But the input to the BMS rely on this little gadget, which is a differential pressure switch. When the pump works, it will create a low pressure on the return and a high pressure on the flow. In that case, the differential pressure switch will close the circuit. And if we'll come back now to the BMS, I will explain to you what happened. On the superior side of the BMS, as you'll see DO1, DO2, DO3, etc., we have the digital outputs which will enable pumps, boilers, chillers, etc. On the lower side, we have universal inputs and outputs. Now, this BMS control will send an input to the differential pressure switch, and when the differential pressure switch will close, you will return the input. In that case, as per its software, the BMS will know that the pump is running. Once the pump runs, the BMS will enable, in our case, the gas booster. Why do you use a gas booster? The reason why we use a gas booster is to make sure that we provide the right quantity of the gas to sustain a correct and normal function to the boiler. But this gas booster is provided with two pressure switches, which can be wired directly into this LMU, the boiler, or if the designer chooses, it could be wired into the BMS. You wouldn't know this unless you'll be lucky enough, which very rarely can find the drawings, which is not the case all the time. So if the BMS will receive the information from the gas booster, first from the pump, then from the gas booster, and you will be a heating demand, then the BMS will enable the boiler. In that case, the LMU inside the boiler will receive an input from the business management control. Once the input is received, it will start the running protocol. It will check if this over temperature switch it is not tripped, and then it will start running. Once the boiler starts running, you will start first with the fan. Once the fan starts, we have proven switch, differential pressure switch, that's called a proven switch, which will sense the positive pressure or negative pressure. It's up to how it was wired. It could be normally is normal on, but it could be with double function to check itself in normal close, and then it will open the circuit to close another circuit. There are many type of boilers, but this one, as I can see on his specification, is got only 2 wires, so the switch can support normal close, normal on, but unfortunately this switch doesn't check itself. It's got only normal on, so when the fan will start, this switch will close the circuit, and then the boiler will go to the next stage, and the ignition module will be enabled by the LNU. Then the gas valve will open, and for a couple of seconds the function of these ionization probes will be bypassed, and then if the flame does not occur, or if there's any other reason where the ionization probe will not send the right signal to the LNU, the boiler will cease the work, will lock on safety mode. So even if you are a gas engineer, you can be very frustrated. You can repair the boiler, you can repair the pump, but if the running protocol of the business management control is not correctly written, you have to get through a lot of frustration, because the BMS is driving the boiler, and if it's not correctly set up, then will force the boiler on different stages without any justification, and the boiler will prematurely die, or you won't be capable to hit the building as it should. At this stage, the most important thing to remember it is that anytime you have a BMS integrated, you have to check the documents, and you have to find out what part of control is integrated into the BMS, and what part of control is integrated directly into the boiler's local controller. Because believe me or not, this type of integration will be different from store to store, from home to home, and it is not something, it's not a law where the designer will respect the same rule. I found a lot of mistakes where half of the system is integrated directly onto the boiler control, and half of it is onto this BMS control, and because of that you might have the surprise that the boiler will be enabled by the BMS but hold off on safety because the pump was not enabled. So when this happens, you will be frustrated to have an error code onto the boiler without any justification, and then you will be asked by your manager why the job is not done, why it's not working, and to the best of your knowledge you did the best, and yet the boiler is not running. So the BMS, the boiler, the pump, the sensors, they are monoblock, and then you have to understand all of them. Thank you.